deep learning, machine learning, artificial intelligence, neural networks, generative AI, large language models, transformers. People seem to use all these terms interchangeably, but they are not the same. So what on earth do they really mean? And can somebody please explain all this jargon without using even more jargon? If that's how you feel about AI buzzwords, you've come to the right place. In less than 1 hour, I'm going to give you a super concentrated AI intro that will allow you to understand AI better than 99% of the population. I'm going to explain all the terms that you see on the screen, and I'm going to do it visually, connecting them inside one single diagram so that you won't forget them. And also, I will explain them in completely plain English, because I've noticed that the majority of videos that promise to explain AI concepts easily are not living up to the promise. I'm going to use zero extra jargon, but at the same time, I'm going to keep it precise and accurate. I will only omit the details that are not necessary to understand the big picture of this AI concept, because my goal here is to focus on the big picture of each concept, on why they really matter to you, to your business, your work, or to society. After watching this video, you will be able to have an educated conversation about AI that, to be honest, very few people can have today. This is the third video in my course, The Big Picture of AI. But if you only have time to watch one of them, just focus on this one. This one is the most useful for quickly getting up to speed with artificial intelligence as a whole. Okay, let's get started. Level 1. Our first concept is this all-encompassing red circle, AI, artificial intelligence. And I'm sure 99% of you already know what AI means, right? AI simply means the intelligence displayed by machines, like computers and robots and self-driving cars, as opposed to that present in living things. And AI is created using a sophisticated type of software. Yes, being a piece of software is one important characteristic of all AI. Perhaps at some point in the future, we will build our AI using some form of artificial biology or some special hardware imitating the structure of the brain. But for now, all our AI is pure software that oftentimes can even be run on general-purpose computers like the latest Apple laptops. And before looking at the next level of the AI family, I will just give you one big picture idea about this level. It's something profound that many people don't understand about the concept of AI as a whole. But if you understand this big picture idea, then everything else falls into place. And you immediately get why there's such a frenzy and such a gold rush around AI. AI is the most important invention in human history because it is the only invention that can invent. AI is the meta-invention. Or to be more precise, AI will be able to invent as soon as the AGI level is attained. Because AGI is the end game of all those state-of-the-art tech companies that are taking part in the AI Gold Rush. And what is AGI? Well, we will get to that, but we must first understand the next level of our diagram. Level 2. The first main divide of the AI family is between the two main approaches that AI researchers have tried to create intelligence. These two approaches are symbolic AI and machine learning. There are also other approaches, but they are not as important. And in this video, we are only focusing on the most important concepts of AI. So these two main approaches have existed since the beginning of the AI discipline, back in the 1950s. But their importance have changed dramatically. From the 1950s until the beginning of this century, symbolic AI was by far the leading approach. And that's why you will also hear it referred to as classical AI or classic AI or even tongue-in-cheek as good old-fashioned AI. Then from around the year 2000 until today, they've completely switched places. And it's now machine learning that gets almost all the research attention and makes companies all the money. Actually, machine learning has become so successful that you will see it frequently used as a synonym for the entire AI sector. That's why on job listings, you will see the job title Machine Learning Engineer instead of AI Engineer. But we are here for the big picture, and you may be wondering what is the main big picture difference between the two approaches? Well, as I said earlier, the end product of both approaches is always a piece of software. But what these approaches try to put into the software is radically different. The symbolic approach tries to first figure out the rules of thought, to then write those rules directly into the software code. Machine learning, on the other hand, starts from the premise that finding all the rules of thought is extremely difficult, if not impossible, and instead tries to build a piece of software that can learn the rules by itself. A very rough metaphor would be that symbolic AI is trying to build a finished mind, whereas machine learning is trying to build an empty brain, with the hope that after exposing that empty brain to lots of information, it will develop its own mind. A bit like a baby learns to think over the years after lots of exposure to sensory information. That's why machine learning is called machine learning, because they are really trying to make machines that can learn to think. By the way, you will also sometimes hear the symbolic approach being referred to as rule-based AI or logic-based AI or even formal AI, because this approach is trying to formalize the rules and logical processes that go in our minds to then write them directly in the software code. As I said, these days, symbolic AI has shrunk dramatically in importance, and there aren't many popular examples of symbolic AI that we may come across in our everyday life. But I will give you two examples that were very popular in the 1980s and 1990s and that are still frequently mentioned to this day. One of them is Deep Blue, the AI that for the first time beat the top human chess grandmaster back in 1997. Deep Blue was symbolic AI. The AI researchers who created it had to manually input the chess strategies directly into that piece of software. Deep Blue didn't learn the strategies by itself. It was just very fast at searching through all the strategies that they had put inside its software. In contrast, in 2017, AlphaZero was a machine learning AI that, like Deep Blue, managed to beat all the human grandmasters. But this time, thanks to machine learning, nobody had to manually input the chess strategies into it. AlphaZero learned the strategies by itself, by just playing. That's the power of machine learning. Another example of symbolic AI that was quite successful in the past century was something called expert systems, which were the protagonists of the 80s AI hype wave. These were systems used in medicine, finance, law, and other fields for expert decision-making. But again, although they did work for some use cases, they also required humans to encode all the rules by hand. If this happens, then do that. If that happens, then do this. And obviously, all those human encoded rules were extremely painstaking to create and a nightmare to keep up to date. Today, there are some surviving remains of them in some medical decision-making systems, etc., but they have for the most part been superseded by machine learning or hybrid systems. As for successful examples of machine learning that are around us today, there are countless ones. But before going into some of the most famous, we need to first understand the next divide within machine learning. Level 3. Machine learning can in turn be divided into, on the one hand, neural networks, and on the other hand, all the rest of machine learning that don't use neural networks. Examples of machine learning that don't use neural networks probably won't sound too familiar to you because they are by no means as important as the neural networks approach. So I won't cover them in this big picture video. The important thing is that the machine learning approach that has produced the best synthetic thought by far is the one that uses neural networks. And in retrospect, it is not surprising that this approach has been so successful. If you remember, I said that the machine learning approach is to create a thing that can learn to think, instead of creating thought itself. Well then, if you wanted to make a learning machine, wouldn't it make sense to try to design a machine that imitates the only thing in the universe that we know that can learn? That thing is the brain of animals and humans, and neural networks is indeed the type of machine learning that is directly inspired by the structure of the brain. That's why you will also hear this type of AI referred to as artificial neural networks, with the artificial added to stress the difference from the biological neural networks that make up human and animal brains. And also sometimes you can hear the shorthand neural nets. It took neural networks more than 50 years to begin to produce any significant results. But when they began to work, boom, they started the current AI revolution. And why did they take so long to work? Well, that's for another video, but the TLDR is that we didn't have enough computing power to create big enough neural networks, nor enough data to teach those giant neural networks how to think. And by the way, how do neural networks work at all? They sound fancy, right? Very sci-fi-esque. And they deserve that allure because they are an absolute technological miracle. They can learn pretty much like our brain can. Yes, of course, you will hear that they are very different in the structural details, and that's true, but the big picture principle of how they function is strikingly similar. In the case of our human brains, we are born with an almost virgin neural network in which very little information or thought patterns are stored. Over the years, we are exposed to lots of visual information, voices, sounds, smells, etc. And little by little, our neural networks begin to interconnect in a way that reflects all that information, and that's why little by little we learn to think. A baby of a few days is not much smarter than an earthworm. Sorry to be rude to the poor baby. And yet, a few months of exposure to sensory information begin to wire the baby's neural networks in ways that allow the baby to make increasing sense of the world. In the case of artificial neural networks, it is the same. The neural network is a software program that simulates neurons. In AI, they are called nodes instead of neurons, and the connections between them, just like in the brain. And just like our brains, the artificial neural network is exposed to visual information or textual information or a combination of them, until little by little the connections between those digital neurons begin to set themselves in a way that produces the ability to understand the world and produce something similar to thought. Some experts say it is real thought. Other experts say it is just a simulation of thought. But we won't cover that controversy in this video. What matters for the big picture is that, simulated or not, this thinking is strikingly similar to our own, and for many practical purposes indistinguishable, and sometimes even superior. And one last buzzword before we move to the next level. Since brains are so interconnected, and since neural networks are inspired by brains, you will also hear sometimes neural networks referred to as the connectionist approach. Okay, so if neural networks are the AI that imitates the architecture of the brain, what is deep learning then? Level 4. Deep learning is nothing but a type of neural network that has many layers of artificial neurons stacked on top of each other. And that's why this approach is also called deep neural networks. And once again, deep learning is such a famous term because it is the most successful approach within neural networks. The other type of neural network that is not deep learning is shallow neural networks, which have only one or very few layers of neurons. But nobody uses those anymore because they don't allow to achieve sophisticated learning like the deep ones do. So as soon as the technical difficulties to create deep neural networks were overcome, the shallow approach was abandoned, and deep learning and neural networks are today almost interchangeable terms. Can you see the pattern? All the terms that we've seen so far were the most successful approach within its parent category. Deep learning is simply the most successful approach within neural networks. Neural networks, the most successful approach within machine learning, and machine learning, the most successful approach within AI. And this is why it is so common to hear these terms mixed up in conversations about AI. People often talk about deep learning, neural networks, machine learning, and AI interchangeably because they are just talking about the AI approach that has taken over almost all of the AI sector, using different names to refer to it. And that approach is deep learning neural networks. Because the huge majority of the AI sector today revolves around using deep learning neural networks. Okay, but now it's time for the next level. And this is also a term that I'm sure you've heard a lot about. Level 5. Deep learning can be used for many things, but the type of deep learning application that has been making all the noise and headlines for the past couple of years is the type that can create content. And that type is called generative AI, artificial intelligence that can do things like writing text, composing melodies, or drawing cartoons. The name generative AI comes from the fact that it can generate content, and it is also sometimes abbreviated as Gen AI. Unlike all the previous levels we've seen, generative AI is not another approach or another architecture to try to create AI, but an application of AI, an use case. But I've included it inside deep learning because there's virtually no AI that can generate good content and that is not based on deep learning. Virtually all generative AI is powered by deep learning neural networks. But why did everybody begin to talk about generative AI so suddenly in 2022? Because before 2022, generative AI was still very experimental, and the quality of the content it created was still poor. That's why when in 2022 this type of AI started to produce very decent images and text, people began to pay attention. And then when at the end of that year, OpenAI released ChatGPT, which produced great text and was very easy to use and free, well, the word of mouth made it viral overnight. Indeed, 2022 was a revolutionary year for AI. All of a sudden, AI could generate text almost as well or better than most humans. And same with images. In a matter of seconds, people could create the type of artwork that would have required hiring a professional illustrator and wait for days. Level 6. Transformers and diffusion models. These two terms can sound particularly intimidating. They are also tossed around a lot in AI conversations, but few non-technical people know what they are. Well, don't worry, because the truth is that to understand the big picture of AI, you don't need to know how they work in detail or any other nitty-gritty about them. You just need to know that they are simply two types of neural network. And of course of the deep neural network type, not the shallow type. That's why they fall under deep learning. And finally, you need to know that there are many other types of deep learning neural networks, but people talk so much about these two because they have produced the two biggest success stories in generative AI. Level 7. Diffusion neural networks have produced the text-to-image models, and transformers the text-to-text models. Text-to-image models, also known as image generation models, are the ones in which you input the description of the thing you want and the model creates it for you in seconds. Some popular examples of this type of model are DALL-E, Stable Diffusion, and Midjourney. As for the text-to-text models, also referred to as text generation models, they can be used for many different things. But the most popular use case right now is chatbots. That's why sometimes this entire category is simply referred to as chatbots, even though it is much more than that. By the way, another piece of jargon, model. In the world of AI, when we say model, as I've just been doing, it means a piece of software, a program. If, for example, someone says that they are going to release a new text-to-image model, that's like saying that they are going to release a new text-to-image program. Level 8. And in this level comes in another super popular AI buzzword, LLMs. LLM stand for Large Language Model, and they are very simple to explain. An LLM is simply a text-to-text model that is especially big. Actually, LLMs are gigantic compared to the neural networks that AI engineers could create until very recently. These mega neural networks have been made possible by advances in the computing power necessary to run them and by accumulation of the enormous amounts of data necessary to feed them information from which they can learn. And LLMs have become so very famous because you know who is an LLM? Yes, our celebrity friend ChatGPT. ChatGPT, the biggest success story in the history of AI, is an LLM. And that's why LLMs are also in everyone's mouth. Once again, the pattern repeats. Text-to-text models are the most popular variety of generative AI. LLMs are the most effective way to create text-to-text models, and ChatGPT is the most popular LLM. Or to talk accurately, the model behind ChatGPT is an LLM, not ChatGPT itself. ChatGPT is not really a model, it is the customer-facing facade of a model. It is an easy-to-use chat service that allows people to easily use the LLM model known as GPT. In 2022, when ChatGPT was first launched, it had the GPT-3 model under the hood. And now, at the time of filming this, it has the GPT-4 model under the hood. Like computer operating systems, OpenAI, the company behind these models, gives its models a new number when they release a new improved version. Another important thing to know here is that these large language models can and are being used for many other things, not just to talk with them via chats like ChatGPT. For example, you can pay OpenAI, the company behind the GPT models, to connect an app, a website, or any other business application that you may possess, and have GPT provide the brain power behind your service. Just one example, you could create an application called My Writing Pal that gives authors suggestions about how to improve their novels and have GPT-4 under the hood providing the intelligence to generate those suggestions. So in this example, My Writing Pal or ChatGPT are just user-facing applications that use the GPT-4 large language model to provide the intelligence. By the way, if you are seeking advice on how to adapt your business or your career to the AI age, you may want to book a discovery call with me. I specialize in AI transition consulting and provide guidance to individuals and business owners who are concerned about the potential impact of AI on their career or on their business, or who want to know if they can leverage AI in their current occupations to become more competitive. The discovery call is free, and I will only take you as a client if I am confident that I can help you, because not everybody is a good fit. If you are interested, the link to book a discovery call is in the description. Out of all the types of AI models that exist today, LLMs are by far the most important economically. Before 2022, few people were aware that by just making this type of neural networks very large, they were getting so good at understanding human language. In fact, they've gotten so good at it that today, virtually all AI text generation is done with LLMs. But also LLMs, as we build them even larger, are starting to get better at many other things beyond text generation. So to reflect the current state of things, this would be a more accurate representation. Transformers and LLMs extend out of the generative AI area because they are also being used for other non-generative use cases, as we will see in the next section. The big picture inside here is that right now LLMs are seen by the big tech companies and by some powerful governments as the philosopher's stone of AI. That is, an AI that potentially, as it keeps growing larger and larger, might be able to do pretty much anything that its masters command. And that's why all the big tech players are obsessed with LLMs, have their own LLMs, are building their own LLMs, or are investing in AI labs that own an LLM. The most powerful LLMs right now are the already mentioned GPT, of course, developed by the AI lab OpenAI, which is partly owned by Microsoft. Claude, developed by the AI lab Anthropic, which is partly owned by Amazon. Gemini, which is Google's LLM. Llama, which is Facebook's. And finally, Grok, which is the one created by Elon Musk's AI lab, xAI. Beyond generative AI. Now we have to go back up to level 5 for a minute. As I said, generative AI is the better known use case of AI at the moment, but there are other two very important use cases that you will hear about. Interestingly, one of them is actually older than generative AI, and the other is not even ready yet. But when it is, it will rock our world even more than generative AI has. Discriminative AI. Discriminative AI is a type of AI use case that is not focused on creating content, but instead is used for making classifications and predictions. This type of AI has been with us for a long time, much longer than generative AI, but it is rather invisible and as a result is not as talked about as the generative AI revolution. The examples of this invisible intelligence in your daily life are countless. Discriminative AI is what decides, for example, if an email sent to you looks like spam and shouldn't be shown in your inbox. Under the hood, email apps are using discriminative AI. And that's why this type of AI is called discriminative, because it discriminates. It classifies things into categories. In this example, the categories would be spam and not spam. But as I said, discriminative AI can also make predictions, and you sometimes can hear this entire type of AI referred to as predictive AI. The most famous examples in which discriminative AI is used for prediction is online recommendations. the type of recommendations that you get about films to watch next on Netflix, or products you may also like on Amazon, etc. All these use AI to try and predict what you may like in the future based on what you liked in the past and other types of actions that you did. And you know who also uses discriminative AI? YouTube. And I know it is a cliche, but it is true. If you subscribe to this channel or comment on this video or even just like it, you will be giving important clues to the YouTube algorithm as to the type of content that you like to see in your recommendations. And by the way, is all discriminative AI also built using deep learning neural networks? The answer is no. In reality, unlike generative AI, for discriminative AI, other types of machine learning that don't use neural networks are used too. So to be fully accurate, we would need to include discriminative AI here too. Agentic AI. So discriminative AI was the first use that most of us experienced, but also the most discreet, almost invisible one. And then generative AI was the type that took a lot of time to mature, but when it did, it quickly grabbed all the attention due to its sci-fi-esque, almost magical quality. The machines make pictures and talk. How crazy is that? Well, as much as these two types are extremely useful and will continue to be a big part of our lives, the third type, agentic AI, will be the one that will transform our world the most. I will explain why in a minute, but first, what exactly is agentic AI? Agentic AI is, as the name indicates, the AI of agents. And what are AI agents? In the AI context, agents are pieces of AI software that can be autonomous. That's why you will see this category also referred to as autonomous AI or autonomous AI systems. And by autonomous, we mean pieces of AI software that can take actions in the world by themselves and not just exist inside a confined, controlled, and limited application. For example, ChatGPT is very smart, but all it can do is answer questions and it is trapped inside its website. You can't ask it to go do stuff for you on the internet or send emails or phone people on your behalf. An AI agent, on the other hand, could potentially be as smart as ChatGPT, but be able to go do errands for you, and at some point, when they get smart enough, they would be able to even carry out entire jobs. So the main way to think about agentic AI is that it is an AI that can act. An AI butler, an AI secretary, or any other type of AI-powered virtual assistant would classify as an AI agent. And actually, strictly speaking, you already know and probably have interacted with an AI agent. Siri and Alexa and the Google Assistant are all AI agents, but they are so limited in intelligence and in their amount of freedom that most people don't even consider them agents yet. The idea is that as agentic AI gets smarter and more reliable, AI agents will be given more freedom of action and will ultimately become very useful personal assistants to which we will give control of our entire computer, phone, passwords, to make our lives easier. But one day, AI agents could also become AI workers, that is, AIs that can replace an entire white-collar human employee. And things don't even end up at white collars. AI is a piece of software, so in principle, it can only act in the world of the internet and in the world of phone calls, etc. But we can also put that software inside physical machines that can also act in the physical world. And this would be the second flavor of AI agents, physical AI agents. You may hear this second flavor of agentic AI referred to as embodied AI, or in everyday speak, robots and androids. By the way, you probably know this one, but android simply means a robot with a human shape. Androids have so much economic potential because they can directly be used anywhere where a human worker already works. The work environment doesn't need to be adapted to the shape of a bulky or odd-shaped robot, because the android already has the shape and movements of a standard human. So if this type of robotic AI agents become intelligent enough, the replacement of blue-collar workers could be seamless. So to recap, the two main categories of agentic AI are virtual agents and robots. Probably now you can see how revolutionary agentic AI could be. The automation of jobs that started in the first, second, and third industrial revolutions could come full circle when the machines and the computers that until now needed human operators start to be able to act by themselves. You can check out my video on the upcoming employment crisis in the top right corner of the screen. Thanks to AI agents, the amount of wealth created will have no precedent in history. But the scale of job destruction will also be enormous and will require rethinking our current economic and social structures. But I said that agentic AI wasn't quite mature yet. So why is that? What is missing before we can have AI-powered workers? The main things that are missing are two ingredients. First, an ability to plan, and second, reliability. As of today, the most intelligent form of AI that we have managed to create are the deep learning neural networks of the LLM type. LLMs are not just good at creating cheesy poetry or to summarize text. These neural networks are so big and have been exposed to such a wealth of information that they have learned to think about a lot of stuff and have developed a certain amount of common sense and also understand human needs and human culture in a lot of detail. So in principle, they could be great candidates to be the brains of these AI agents. But despite these advanced cognitive skills, LLMs are still lacking in planning and reliability. LLMs are not very good at creating action plans and following them or readjusting them if they find obstacles along the way. Also, when it comes to their thought processes, they are not as reliable as the average human yet. Sometimes their logical reasoning breaks, and sometimes they invent things that are not real, without even being aware that they are making things up. That's what we call LLM hallucinations. So for now, nobody knows when useful and safe AI agents will be available. We can say that agentic AI today is at a similar place where generative AI was before 2022. Lots of experiments and prototypes are tried all the time, but the quality isn't enough to make them revolutionary just yet. And what about the place of AI agents in our diagram? Well, precisely because this type of AI is still so immature, nobody knows how exactly it will be built when it gets mature enough. But for now, the approach is oftentimes hybrid, using deep learning neural networks, but also other types of machine learning and also some forms of symbolic AI. One example is a type of robotic agent that we call the fully autonomous self-driving car. Yes, self-driving cars are also a subtype of robot. The state-of-the-art self-driving cars like the Waymo taxis that already operate in a few American cities use a mixture of all those three types of AI. Whereas this hybrid approach continues to be the case, nobody knows. Some people have hopes that the upcoming versions of the large language models, like the future GPT-5 or GPT-6, or those from its competitors, will be so intelligent that agentic AI could be achieved based solely on them. They hope that these upcoming generations of LLMs might learn to plan and avoid hallucinations by themselves, just like they learned so many other skills in previous versions. In fact, this phenomenon of LLMs learning spontaneously new skills as we build them bigger received its own buzzword: emergent properties. And since emergent properties are not designed but just emerge out of the process of LLMs gobbling up lots of data and learning from it, they are unpredictable. Nobody knows what new skills the next bigger generation of LLMs may learn, because machine learning, as we said at the beginning, is not designed intelligence, it's grown intelligence. We are just creating the thing that learns. We are never quite sure how much the new, bigger neural network to which we are feeding even more data will be able to learn. It's very exciting, but it can also be seen as quite scary. And speaking of extremely smart AI, our final two AI types are all about that: AGI and ASI. Up to this point, we've seen the different approaches to use and build AI. But in reality, what we humans have been building so far is a particular type of AI that can be called narrow AI. So in reality, AI as a whole goes beyond this current narrow stage of AI, and there are other two types, AGI and ASI, that are still speculative, but which are important to know because they come up all the time in conversations about the future of AI. So AI is the global term. It is simply any type of intelligence that is created artificially, synthetically, irrespective of how smart it is. Narrow AI is the current stage of AI development. It's called narrow because, unlike human intelligence, it is not great at being flexible and adapting itself to many different tasks. It has narrow capabilities. Some of these narrow AI systems are better at talking, others at driving a car, others at composing music, and so on. Then AGI would be the next stage, being as intelligent and flexible as a human. And finally, ASI is AI that is far beyond the average human capabilities. So let's look at the two new types in a bit more detail. AGI stands for Artificial General Intelligence, because whenever it is achieved, AI will be good at everything humans can do, not just narrow parts of our abilities, and thus the general in it. Ever since the beginning of the discipline in the 1950s, AGI has been the ultimate goal of AI researchers. Creating machines that could be as smart as a person was always the pipe dream. It's alive! Two very popular definitions of AGI are: first, artificial intelligence that is at least as good as a human at anything a human can do. And second, the OpenAI definition, which is surprisingly sincere. Here is one of its most popular employees explaining what they are trying to build.
What is an AGI?
Yeah, so AGI is artificial general intelligence. OpenAI's definition of AGI is when these artificial intelligence systems are able to do all economically viable work that a human is able to do. All economically viable work that a human is able to do.
Basically, according to this definition, AGI is the perfect human worker replacement. But if you think about it, both definitions are saying the same thing with different words. If something is as smart as a human at everything, it is just a logical consequence that that thing could also do all the human work. All the top AI labs like OpenAI, Anthropic, and Google's DeepMind openly admit that their current goal is to build AGI. These labs also openly admit that achieving AGI could be just a few years away. I hope this gives you a big picture understanding of why corporations and investors are so obsessed with getting into AI. When they talk about the AI potential, they are often thinking not just of the current type of AI, but of the end game, AGI. Because if the top AI labs are right, then a technology that could replace virtually all human workers is within just a few years' reach. And the owners of that technology could make extraordinary amounts of money. And where does AGI sit in our diagram? Well, nowhere yet, because nobody knows what type of AI architecture will lead to AGI when it is achieved. Some leading AI scientists like Ilya Sutskever think that the current neural networks of the transformer type, the ones we use to make LLMs, will be able to lead to AGI. We would just need to keep making them bigger and feeding them even more data, and the emergence of skills that I mentioned earlier will make them reach human-level cognitive skills. But other equally reputed AI researchers, like Demis Hassabis, have said that more hybrid approaches may be required, perhaps using other types of neural networks, not just transformers, or perhaps using a combination of neural networks with other types of machine learning, or perhaps even a mixture of symbolic AI with neural networks called neurosymbolic AI. And let's finish with the most sci-fi-esque of all the terms. This is less commonly heard in the mainstream media for now, but there's no dinner party in Silicon Valley in which this term is not brought up at some point. In the heart of tech land, everyone's obsessed with AGI and ASI. ASI stands for Artificial Superintelligence. The super accounting for that superhuman intellectual ability beyond that of us, Homo sapiens. And being more speculative, ASI is even more loosely defined than AGI. Some people use ASI to refer to the level of AI in which it will be not just as smart as average humans, like AGI is, but smarter than the smartest of human geniuses. But others put the threshold even farther. and use ASI to refer to artificial intelligence that is smarter than all of humanity put together. At any rate, it is a common view in AI circles that once AGI is achieved, ASI will be achieved soon after. Why? Because one of the first things that AGI-powered agents will be tasked with? AI research. The moment you achieve AGI, you can create lots of AGI-powered scientists that do research about AI itself. These AGI-powered scientists are as smart as a human, but much faster because they are computers and have computer speed. That's why after AGI is achieved, the speed of AI development will accelerate. This is sometimes called the intelligence explosion. That is the self-reinforced loop in which AI creates better AI. So before we know it, AGI will have discovered ASI. And in turn, ASI will be great at improving itself even further and faster, until it dwarfs all of humanity in intelligence. That's why some people say that the big AI labs are trying to build an AI god, because they really are trying to. In this video, I'm not covering the speculations about whether such an AI god is possible or not. We are sticking to the facts and the definitions here. And the fact is that these labs want to build AGI and that they believe AGI will discover ASI. There are many other AI concepts I haven't covered in this video because I wanted to really focus on the most frequent ones. But if you like this one, I will make another explaining in very plain English all the types of supervised learning, unsupervised learning, reinforcement learning, etc. And things like inference, fine-tuning, parameters, weights, GPUs, TPUs, natural language processing, and many other things that are useful to know if you want to get into the level 2 nitty-gritty of AI. I will also make a video on the speculative side of AI, going into more detail about the singularity, the post-AGI intelligence explosion, the Kardashev scale of technological civilizations, and the various forms of transhumanism, along with the scenarios of alignment and misalignment in our relationship with artificial superintelligence. Just let me know in the comments what you'd like me to cover. Anyway, thank you so much for watching this video and see you soon.